What's going on, ladies and gentlemen? Welcome to another edition of Math with Mr. Stevens. Today we're going to be in lesson 27, taking a look at systems of equations and looking at different ways to solve them than just graphing. So we take a look at graphing a little bit earlier in the week, and today we're going to look at another way of solving a system of equations, and that way is going to be through substitution. Okay, substitution is my favorite method. It is the method that makes most sense to me. There is another method that we will be talking about a little bit later on, and that is called elimination. So we'll have some of those here in the future, but for right now we're going to deal with substitution. And substitution is going to work very well with the examples that we are going to do. They're going to be in Module 4 on page 336. So grab a pencil or a pen, and then grab your book and open up to page 336, and we're going to look at exercise number 5. Okay, so let me zoom in just a little bit here so we can focus on here. We've got plenty of room for us to work, and then we've got this set of linear equations here that we're going to have as a system. So we have to find the solution to this problem. Okay, and so in using substitution, the way this is going to work is we're going to take a value that has been solved for us, a value that has been given to us, and that's usually in the form of a slope-intercept form equation. And in this example, that is what we have. We have y equals 3/2 x minus 1. That is in slope-intercept form. We also have another equation. It's not in slope-intercept form. It has a coefficient of y, so it's kind of halfway in between slope-intercept and standard form. So that is what we've got for right now for us to work with. And so when we are dealing with systems of equations, they can really be in any form possible. Usually they're going to be in either slope-intercept form or standard form, but they can also end up being somewhere in the middle where we just have a coefficient of some amount of y's being equal to something, some amount of x's being equal to something, and we just have to be able to kind of work with what we're given. So with this particular example, because it is slope-intercept form, that makes it really easy for us to substitute. And the way this works is we take the value that's been given to us for y, or for x, we may have a value for x to solve with, and we're going to take it and plug it into the other equation for that variable. So in this instance, we're going to take 3y, and in place of y, we're going to have this whole thing here. So that whole thing is going to go in for y. So 3/2 x minus 1 is going to go in for y, so our equation now looks like this. 3 times 3 over 2 x minus 1. So we take the whole expression that y is equal to and plug it into our equation for y is equal to x plus 2. Okay? And so to be successful with substitution, we have to be able to, number one, plug a value, or plug, in this particular instance, an expression into an equation for a variable. Number two, we have to be able to distribute properly and then combine like terms to solve and do all of those things successfully. Okay? So what we're going to do is we're going to distribute. So we're going to take this 3 and multiply it times both of these values here. So we're going to get 3 times 3/2, which is going to give us 3 times 3 is 9, 9 over 2. So it's going to give us 9 over 2 halves, or 9 over 2x rather, and then 3 times -1 is -3, and that's equal to, this side has not changed. We haven't done anything with it yet. Okay? So this is our value. This is what we've got to work with. Now we need to just solve for x. We've got x on both sides, so we have to eliminate one of them, and then we have to move our constants. So we have had problems like this in the past. It's been quite a long time ago that we've solved an equation like this. But there's a reason we did all of those things several weeks ago, several months ago. It's because we're going to need them to be successful here in solving a system of equations. Okay? So we're going to subtract x from both sides. So we're going to subtract 1x. So 9/2 minus 1x, 9/2 x minus 1x is going to give us 7/2 x minus 3 equals 2. Okay. The way I figured that out is I take 1x and turn it into a fraction over 2, which would be 2 over 2. So then 2 over 2, and taking that away from 9 over 2 gives us just 7 over 2. So we have 7 over 2x minus 3, so we're going to add 3 to both sides. So that cancels that away, so we have 7 over 2x and that is going to be equal to 5. Okay. Now here's where things start to get a little bit more difficult. We've solved, like I said, lots of problems like this before, and we've dealt with rational numbers lots of times before. Here we're going to have to do it again. All right. So in order for us to get rid of this 7/2 as our coefficient, we have to divide both sides by 7/2. Okay. So 7/2 divided by 7/2 is, of course, 1, which is 1x. And then we're going to have 5 divided by 7/2. So we're dividing a whole number by a fraction. So that means we're going to have to do 5 over 1, keep, change, flip. So we're going to keep that, change that to multiplication, and flip it to 2 over 7. Multiply straight across. And that's going to give us 10 over 7 as our value here. And so our answer for x is 10/7. Okay? So now we have solved half of our equation, or rather half of our system. We know what x equals. Now we need to figure out what y is equal to. Okay? In order to figure out what y is equal to, we take our value for x, plug it back into our equation for y. There's a reason they gave you so much space here, and that is because this is going to get a little bit messy. We are going to have to deal with rational numbers quite often. So we're going to take our value for x, 10/7, and plug it into, I'm going to plug it into this first equation, because I'm not going to have to solve for y. Y is already isolated by itself. So when I plug in a value for x, I just multiply, do all of the math on that side of the equation, and then what is left, that is my value for y, and then I'm done. So I'm going to take y equal to 3 over 2 times 10 over 7 minus 1. Oops, slide that back over. Okay. And what I've done this time, I've just taken my value for x, and now I've plugged it back into my first equation, my top equation, in place of y, in place of x. So now I can solve for y. Y is the only variable that's left. That's the point. So I've got 3/2 over 10/7. So 3 over 2 times 10 over 7. That's going to give me 30 over 14. Okay. So 30 over 14. Very nice. No problem. Okay. And that is, I can reduce that down quite a bit. I can reduce that down to, what, 15 over 7? Yep. So 15 over 7 minus 1, which is 7 over 7. So I'm going to take 1 and turn that into 7 over 7. So I have 15 over 7 minus 7 over 7, and that's still going to be equal to y. And so my value for y, 15 sevenths minus 7 sevenths is 8 sevenths. And so my value for y is 8 sevenths. Okay? Again, two fractions, two, in this particular case, improper fractions, two rational numbers. It's a bummer, but we have to be able to solve equations like this. So my solution for this problem, my solution needs to be as an ordered pair, so it's going to be 10 sevenths, comma, 8 sevenths. And what that does is this represents the place on a coordinate plane where if we were to graph these two lines, this right here, 10 sevenths, 8 sevenths, is the point where both of our lines would intersect. Remember, even when we are solving them without graphing, and this would be a real bummer to solve while graphing, let's be honest with ourselves. Finding 10 sevenths and 8 sevenths on a coordinate plane, usually coordinate planes don't have fractional values on them. And even if they do, usually they're in quarters or halves at most. So having to deal in terms of a fractional value of 7 is going to be a bummer. It's going to suck. So we need to have another way of solving than using graphing, than using a coordinate plane, which we did here with substitution. But it still needs to represent a point that would be on a coordinate plane if we were to graph it, if we were to put it on there. So that's what our solution is. 10 sevenths, comma, 8 sevenths. That's substitution. It can be easy. It can be a little bit more challenging. And the reason I personally like substitution is because this is an opportunity for you to take a math problem and manipulate it into a way that makes things a little bit more easy, makes things a little bit easier for you to deal with, okay? And so we're going to see with another problem, question number 6, the next one on page 337, something similar. We're going to have a different strategy this time of solving. We're going to use something that's similar to substitution, although not exactly, because of the special situation that the next problem provides us. And so if we take a look at that on on page 337, question number 6. We've got x equals 12y minus 4 and x equals 9y plus 7. So what we have here, instead of using substitution, which we could do, of course, instead of using substitution, we would, when we do that, we would take a value for one of our variables and plug it into the other equation for that variable. Well, when we do that, and that is kind of what we are going to do, to be honest with you. When we do that, what we end up with is we have two expressions that are going to be set equal to each other. And so what I mean is, this expression right here, 12y minus 4, that equals x. And this expression right here, 9y plus 7, also equals x. And so when we have two things that equal the same thing, then we can set them equal to each other. So so the top one equals x, the bottom one equals x, so that means the top and the bottom both have to equal each other as well. So that's going to be our strategy. When we have a set of equations that give us essentially the same value for the same variable, we can set them equal to each other. The same thing would be true if we had two equations in slope-intercept form. Y equals blah, 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 and y equals blah, blah, blah. You take the expression that they're equal to and set them equal to each other like this. So we're going to go 12y minus 4 is equal to 9y plus 7. Okay? Now, technically, we didn't use substitution, but we kind of did, because if we were to take this value for x up here, 12y minus 4, and plug it into this equation, we would end up getting 12y minus 4 equals 9y plus 7, which is what we do have. Okay? We're just taking a step forward in logic and saying, well, this equals this equals this, so these two have to equal the same. So from here, we're going to solve for y. So we're going to subtract 9y from both sides. We're going to add 4 to both sides. And so we're going to get 3y being equal to 11. Divide both sides by 3. And so y equals 11/3. Okay? Just kind of hit fast forward on you. But we're just solving an equation. We've done this many times. We've done this successfully a lot. Okay? Now we have a value for y. So we take y, plug it into our equation. And so I'm going to take the bottom one here. So x equals 9 times 11/3 plus 7. Okay? Now I'm going to solve for x. Either way, whichever one we plug this value for y into, it's going to give us the same value for x. It doesn't matter. We're going to get the same thing. All right? This one, the reason I picked it, is just going to be a little bit easier to deal with. The reason why is because when we do 9/1 times 11/3, that gives us 99/3, which is the same thing as 33. So now x is equal to 33 plus 7, which of course is 40. And so x equals 40, and my solution for this system of equations is going to be 40, comma, 11/3. That's it. Remember, x value always goes first. So, two options here. Both of them actually did give us solutions. When we have solutions that have the same line, or when we have solutions that have the same slope, then we have a different scenario. We'll have either no solution or infinitely many solutions. Those are in our notes. So if you do see something like that, you do find something that doesn't make sense mathematically, okay, it's probably one of those two things. So you can always double check those notes. Always plug them into a Desmos calculator as well, just to double check to see if you are correct. You may be, you may not be. So this is two methods of solving. We are eventually going to handle elimination. Not my favorite, but it can be useful in quite a few situations, and it could be a good strategy for you to use. Some people like it better. I'm just not one of those people. That's okay. Okay, it's up to you. I need you to be able to pick a strategy that is going to lead to your success. Whether that is substitution or whether that is elimination is entirely up to you. Okay. For right now, though, these two, substitution and your assignment that you're going to get today, you can solve pretty easily by using substitution. The next ones we take a look at will be elimination. So you have those to look forward to. Adios.